Good morning to all. Thank you very much for inviting me to come here. Uh, I learned a lot about Eve yesterday. Really, I feel very happy to learn the potential of Eve. I'm not a scientist doing with those issues. I will be talking to you about the Amazon, and for many years, decades, I did my PhD under Professor Jules Charney and Professor Shukla at MIT. Then I've been working with the Amazon for 40 years, and mostly relate to the tipping point. And then 2019 onwards, I decided that it was too much warning about the tipping point. I was not doing anything to find solutions. So that's why I start a new project, which is how to construct this new bioeconomy we call bioeconomy of standing forests. I create the term Amazon Green Deal. So let me start by just saying Amazon plays a fundamental role in maintaining regional and global climate equilibrium. The Amazon has the highest biodiversity in the planet. This is 13% of known species, particularly 50,000 different species of plants, 16,000 trees species. For instance, 1 hectare of the Amazon forest has more trees species than all of Europe, just to give you an idea how important it is, the Amazon for the planet. And of course, we know today, after 40 years of biosphere, atmosphere experiments in the Amazon, how important is the Amazon for recycling water. Very efficient recycling, deep rooting systems. A few trees are deep and they share the water near the soil surface. So there's a continuous evapotranspiration. 75% of net radiative energy goes into evapotranspiration, keeping good temperature, 30 degrees maximum temperature, and the soil is 26, so 26, 30 is ideal for photosynthesis, is a evolution. Also, the gas to particles conversion process, volatile organic components, the cloud condensation nuclei. So this is a very efficient system, recycling water. And this helps to produce what we call the flying rivers. The recycling of water is very efficient. Water that enters through the trade wind here, one water vapor molecule recycles 5 to 8 times from the east to the west, turns around the Andes and comes to the central, southern South America. The discharge of the Amazon River is 210,000 cubic meters per second, and the flying river is 200,000. So just to say how important it is recycling, how the forest is efficient in recycling water. However, for the last 50 years, the Amazon faces these big challenges, which is deforestation, degradation, forest fire, and global warming. And so I will tell you a little bit about those risks, those two drivers, global climate change and land use change. And let me see what it is. Oh, okay. Everyone here knows very well the planet is warming. And Tim Palmer showed yesterday as well the tipping elements of the climate system. There are many tipping elements. Very worried. Only 1.15 degrees warmer, and we see this, including some may be very close to the collapse. And I will only raise this issue of 2 of the tipping elements, leading to the one here. The Amazon forest is another tipping element. But let me talk a little bit about the melting of ice sheet in Greenland, and the weakening of the thermal highland circulation in the Atlantic, what impact that has. Of course, the loss of the Greenland ice sheet, the fresh water is turning the Atlantic meridional overturning circulation weaker, and that's causing the North Atlantic here to become warmer. Tim talked about the collapse. I'm not talking here about the collapse. Collapse is a great risk, but just today, the tropical Atlantic north of the equator is becoming warmer. And this is really one of the elements, the driver, first driver, more frequent severe droughts in the Amazon. They are very much today associated with this warming of the tropical North Atlantic, and also, of course, we have had in the last 20 years 4 very severe and extreme droughts. 2005, 2010, 2020, mostly relate to the Atlantic becoming warmer. And of course, 2015-16, the record-breaking El Nino also induced a very severe drought in the Amazon. For instance, 2005, 2010, you see there the Atlantic much warmer, this sea surface temperature anomalies, and that induced severe droughts in the Amazon. And of course, the record-breaking El Nino 2015-16 also, that was the record-breaking drought for at least more than 100 years in the Amazon. So this is, that was the first driver. The second one, land use change, the risks of land use change. This is regional deforestation, forest degradation, and fires. I want to say, to bring this attention here, Professor Shukla, myself, and Pierre Sellers, I was invited 35 years ago by Professor Shukla to spend a year there at that time at the University of Maryland doing this work, Amazon deforestation and regional climate change. So we produced 2 papers, 1990 and 1991. And that was the first paper really calling attention to what we call the hypothesis of Amazon savannization, which is one is forest, 6 is tropical savanna, and when you do deforestation here, the new climate, post-deforestation climate, is too dry, too long dry season here, and that becomes a tropical savanna. That was 1990, 1991. What's the hypothesis at that time? Deforestation in the Amazon was only 7% in 1990. But now we have all these areas here. You see the forest areas. They are mostly in the southern Amazon here, but also along the Andes, Peru, Ecuador, and Colombia. Very high rates. This 2022, 40,000 kilometers of tropical deforestation all over the planet, mostly in the Amazon. You can see here 1986 in Bolivia, Amazon, and the 2022, the same area. This is Brazil, Western Amazon in Brazil, 1985, 2022. There's very severe deforestation, mostly in southern Amazon. And here, we have 40 years of research seeing what you do when you replace the forest with degraded, say, pasture, but most of the livestock farming pastures there, they are degraded. Very poor nutrients in the soil, so the pasture becomes degraded. This is, I'm just putting here together 40 years of research. The first one was a UK-Brazil collaboration. August 1983, we established a tower, a micrometeorological tower, 45 meters, and start seeing biosphere-atmosphere interactions. But I just want to say this is a summary of, we had the largest scale biosphere-atmosphere experiment in the Amazon, 1999, even today. So it's more than 25 sites with those towers, forest, pasture, tropical savanna. And I just want to say, you know, the rougher surface, and you have a very interesting thing about the Amazon. Compare During the dry season, there is a lot of evapotranspiration, more than in the wet season, but look at the pasture. 1.5 millimeters a day, here 4.5. This helps a lot maintaining water recycling, very efficient water recycling, and also we form higher albedo clouds. We call green ocean clouds because they are much lower. There is much less also lightning compared to pastures. But this is 40 years of research just to say stronger water recycling in the forest, cooler, and longer dry season, mostly because we have this very high transpiration during the dry season. So we know very well the risks of the Amazon. So also in the last 10 years, there is a very large increase in forest degradation, mostly understory fires spreading through the forest. I did not say before, but over tens of millions of years, the forest is closed canopy evolved. Only 4% of solar radiation reaches the forest floor. So it's very wet. When there is a lightning strike, ignited fire does not spread. Spread for a few meters. Now we are seeing this forest degraded, really creating these risks due to also selective logging, edge effects, hunting, and climate change. Here, a recent paper published showing the forest degradation, increasing tremendously in the Amazon, timber extraction, fire, edge effects, and extreme droughts. As I said, we had 4 extreme droughts in the last 20 years. And a lot of emissions also coming from forest degradation. So recurrent fire alters species composition. So we're seeing also this spread of fire affecting the species composition, biodiversity, and also unsustainable expansion of cattle pasture. 90% of the first deforestation in the Amazon is for a pasture, for cattle ranches. There is a lot of land grabbing. Most of these things is illegal all over the Amazon. Pasture with degraded soil, low productivity, edge effect, fire in the pasture, and particulates and CO2 emissions, CO emissions, sorry, this pollutant and particulate. And so one thing I want to say briefly, increased fire events mostly relate to deforestation, climate change, forest degradation, use of fire in agriculture. Over 90% of forest fires in the Amazon are man-made. So this is not lightning strike ignited fires. And a recent, well, let's say this also 150,000 square kilometers in the last 18 years of forest floors being burned by fires. I just want to say one more. And of course, these forest fires emit these particulates a lot. Particularly is very small, less than 2.5 nanometers, which are very bad for health. And the recent paper show all these areas with a tremendous pollution of these PM 2.5 particles from 2010 to 2019. And this study show the people being affected, 585 cases per 1,000 inhabitants in the Amazon and 227 cases in indigenous territories. There is less affection in indigenous territories because the forest protects a little bit. So just to say, also to show the risks of the forest fires. These are data, observations, just to show how close we are to a tipping point. Very concerned. I feel very concerned about this data, which is dry season in southern Amazon is 4 or 5 weeks lengthier since 1979. 1 week per decade longer all over the southern Amazon, over 2 million square kilometers. All these areas here, it increased atmospheric vapor pressure deficit, hotter, and less evapotranspiration. And because of those things, global warming, deforestation contribute to increase the length of the hotter even dry season, increased atmospheric vapor pressure depth, and increased tree mortality rate. This, in all these areas here in red, the tree mortality is increasing. And so what this is doing is, this is a paper looking at the carbon balance, and I just want to highlight 26% increase in deforestation, 24% decrease in precipitation during the dry season, 2.5 degrees warmer during the dry season, and the green, the total flux, carbon flux, positive is a source, but very concerning. The green means the forest became a carbon source. This is carbon emissions during the wet season, the dry season. It is not deforestation, fires. So this is very concerning. Southern Amazon has become a carbon source, and this is one of the more worry data observations showing how close it is from a tipping point. And I just want to say these are then the two synergistic combinations, land use change in the Amazon and the global warming causing the Atlantic meridional overturning circulation to become, to draw droughts in the Amazon. And this is also many studies we've done. Basically, if we have only deforestation, exceeding 40% deforestation, you get to the tipping point. 50 to 70% becomes this open canopy degraded ecosystem. Or even with zero deforestation, if the global temperature exceeds 4 degrees, you get the same. You exceed the tipping point. Or both together, deforestation more than 20-25% and warming more than 2.5%. So we are very close to that tipping point. If we exceed the tipping point at 30 to 50 years, there will be a transition, losing 50 to 7% of the Amazon, and this is more than 250 billion tons of carbon dioxide emissions, just to show you the risk to the climate stability of the planet. So basically, let me go now to the Amazon Green Deal, to nature-based solutions, what we should do really. We have to stop deforestation, degradation, forest conservation and restoration, have commitments by governments. We are having slightly good news coming from Colombia, from Brazil. Deforestation reduced 40% in the last 6 months of this year in Brazilian Amazon. And of course, the new bioeconomy. We need a new bioeconomy. Let me move quickly. First, how important would be a forest restoration? The forest, the primary forest, not in the southern Amazon, still removes 1.8, 3.6 ton of CO2 per year per hectare. Also, restoration areas can go 18 tons. Heavily degraded pasture, 11 tons. So basically, we are proposing the project called Arcs of Restoration, which is to get to these two areas of large-scale deforestation and more than 500,000 square kilometers create a forest restoration, natural regeneration and reforestation, removing more than 600 million tons of carbon dioxide a year. So we are proposing this Arcs of Restoration project as well. And also standing forests, flowing rivers, new bioeconomy, with also looking at agroecological systems. They maintain more than 6% of ecological services. All of us know the acai berry. I just want to make one example. Acai berry became very important for the economy of the Amazonian people. More than 350,000 people are benefited. $1.2 billion in the Amazon economy, more than 30 products. And just to give a comparison, 1 hectare of livestock farming, $100 per year, and soy, 200, 500, but the agroforest systems, more than $1,000, just to tell you one idea. So basically what we are proposing is a bioeconomy of social biodiversity, value addition to bioindustrialization of forest products, So this is the Amazon Green Deal, a new bioeconomy, standing forest flowing rivers for the whole Amazon, industrialization, rural and urban. This is the concept of social biodiversity, Amazon people, combination of science and indigenous people, local communities' knowledge, creating innovative technologies. To do that, and I will finish quickly just showing an initiative that we are doing now. We are carrying out a feasibility study for the creation of Amazon Institute of Technology, AMIT. Basically, assumption is a knowledge of the Amazon nature based on science and technology as the pathway to sustainable social economic development, environmental conservation. The challenge of valuing indigenous people and local communities' knowledge, a mission of this institute to be a global reference for technological innovation through the use of the information contained in the Amazon rainforest with its gargantuan diversity in terrestrial and aquatic ecosystems, and a goal to transform scientific and traditional knowledge into technological innovation through the formation of networks in partnership with local actors for social inclusion, social economic development, and conservation of the forest and aquatic environment in the Amazon. So basically, ideally speaking, why not to think about, it's a big challenge, but why not go ahead, a CERN or an ICTP for the Amazon. We do not have anywhere in the tropics a high quality Institute of Technology of this quality. So the idea is to be pan-Amazonian, public-private partnerships with a number of innovation hubs. Social inclusion, environmental conservation, education, climate change, and bioeconomy. And so we are designing in 5 thematic areas: Amazon water, sustainable infrastructure, disturbed landscapes. As I said, there are 2 million square kilometers deforested and degraded, so we need to restore a lot of that. Forest and social biodiversity, the greatest potential, economic potential, but of course also urban Amazon. And we are planning a number of graduate, undergraduate education. In all those aspects, I don't have much time to go, but this is the idea. And from yesterday, last night, I thought a little bit after learning a lot about Eve. I said, also in the Amazon Institute of Technology, we are designing a cyberspace. There will be a lot of courses on artificial intelligence, computer science, etc. What's the necessary cyberspace for this new development model for the Amazon? And of course, I was saying challenges of connecting the Amazon Institute of Technology with an, let's say, Eve for the Amazon. Of course, in yellow, climate change, climate extremes, river flows, I'm pretty sure everything that you're doing in Eve has those things globally, including the Amazon. At very high scale, 1 square kilometer, 2.5 square kilometer. But then I was thinking, what challenges we have for new aspects. Can Eve be also helpful? Land cover change, deforestation, degradation, wildfires, air pollution, risks of tipping points, risks of carbon emissions, risk of biodiversity loss, and also risk of zoonosis, epidemics, and pandemics. So I think, also we have to think a little bit how Eve can help advancing on all those aspects as well. So a vision for the present and the future, we have to protect more than 70%. In fact, recent studies show we have, for maintaining biodiversity, 80% we have to protect the forest, 15-20% for this new economy, standing forest, flowing rivers, and only 10-15% for intensive use of regenerative agriculture, mining, etc. Scientific and traditional knowledge as the basis for Amazon sustainable development. This is a big challenge, but we have to face it. And needless to say, how important we all saw this beautiful case a few weeks ago of these 4 Colombian indigenous children. They survived 40 days because they have knowledge that we have to respect, we have to learn with their knowledge. And basically, there is an extremely urgent need to call for global, national, subnational, local actions to save the Amazon rainforest and its people. So this is our major challenge, but we have to face it. We say always, let's save the Amazon, let's save the Amazon people, and the Amazon we want. Thank you very much.